Good morning, calculus students. So Mr. Chen again. So today I would like to talk about the root test. So last time we talked about the ratio test. So what about when do we use the root test? So the root test, once you see the power to the power of n or to the power of a big number, so you want to use the root test. So here's the definition of the root test. So let the series a sub n be series with the non-zero term. So the series a sub n converges if limit n goes to infinity, nth root of absolute value of a sub n, it's less than 1. And then condition number 2, the series a sub n diverges. If the limit n goes to infinity, nth root of absolute value of a sub n, it's greater than 1. And then the third condition, the root test, it's inconclusive. If the limit of nth root of a sub n with n goes to infinity equals 1. So let's try to verify that the example here. So test for the convergence. So this one, we do know that a sub n is 2n plus 3 over 3n plus 2 to the power of n. So using the root test, so we do know that the limit n goes to infinity, nth root of absolute value of 2n plus 3 over 3n plus 2, and then to the power of n. So start with the absolute value. Absolute value makes sure that this whole quantity is going to be positive. So nth root with that to the power of n, so the n got canceled. So what's left here, it's just limit n goes to infinity, and then 2n plus 3 over 3n plus 2. So again, keep that in mind, n goes to infinity, so this one always makes sure that it's positive, because n, it's just a natural number. So 2 over 3, so using the L'Hopital's rule, so we do know that the limit for this one, it's considered 2 over 3. Take the derivative, top and bottom, so we got 2/3, which is less than 1. So therefore, the series converges. And now let's try to verify the other example here. So a sub n, we do know that it's e to the power of 2 over n to the power of n. Well, this one I can rewrite it e squared to the power of n. So basically this one can be written as e squared over n to the power of n. Okay, so just split the power using the power properties of exponent. And then using that, the root test, so n goes to infinity of absolute value, nth root of absolute value of a sub n, so e squared over n, the quantity to the power of n with absolute value. So as you can see that n got canceled. What's left here is just limit e squared over n. And then as n approaches infinity, we do know that it's e squared over infinity. So e squared, that's just a constant over infinity, then that would be 0. So 0 is less than 1. So therefore, the series of a sub n converges by using the root test. So there's more example for this one for the next sections. The next section is about regenerating all those type of tests that we have, alternating series, the ratio test, the root test, the integral test, the limit, with that, the absolute convergence, all those kind of comparison, limit comparisons. So basically we'll go back to it and then try to refresh that. The p-series, the harmonic, all kind. Okay? So thank you for watching the video today. So I'll see you guys next time. Take care.